Welcome students. Today we are going to cover Taylor's theorem, Taylor series and Maclaurin series. So before diving into the Taylor and Maclaurin series, we must be aware about the Taylor theorem. So what's the Taylor theorem? Let me write some of the theory for you. If fx and its n minus 1th derivative be continuous in the interval a to a plus h, and also nth derivative exists for every value of x in the interval a to a plus h, then there is at least one number theta which theta lies in the range of 0 to 1, such that f of a plus h is given as f of a plus h f dash a plus h square upon 2 factorial f double dash a and h cube upon 3 factorial f triple dash a, and so on. It will continue to nth term h to the power n upon n factorial and fn derivative of a plus theta h. Okay, so this is called as the Taylor's theorem. Let us say this is equation number 1, is called Taylor's theorem with Lagrange's form of remainder, and this remainder Rn is represented basically the last term, that is h to the power n upon n factorial f to the power n nth derivative of a plus theta h. Okay, now there are two results derived from the Taylor's theorem. Let us say, taking n is equal to 1. N is equals to 1 means we are only interested in the first derivative. Okay, so can we say, if we take n is equal to 1, then Taylor's theorem reduces to Lagrange's mean value theorem. We have already covered this Lagrange's mean value theorem in the last class or in the last lecture. What was the Lagrange's theorem? That f dash a is f dash c is given as f of b minus f of a divided by b minus a. So this was the Lagrange's theorem. Okay, so now let's, referring from equation 1, this is the equation number 1. Okay, we are taking only the first derivative, and first derivative is up to this term, so this is the only term possible. So let us say f of a plus h is equal to f of a plus h f dash a. Okay, let me rewrite the things for you. Can we write this as a plus h minus f of a divided by h f dash a? Can we say this h this h can be placed here, and what is the meaning of this? F of a plus h minus f of a and a plus h minus of a. So a and a will be cancelled out and the same result will be open. Can we say this is nothing but as compared to the Lagrange's mean value theorem? Okay, so when we are taking only the first derivative, then the Taylor's theorem reduces to Lagrange's mean value theorem. Okay, now let's talk about the result 2. This was the result number 1. Putting a is equal to 0 and h is equals to x in equation 1, what we get? What we did, we are putting a is equal to 0. This is 0, this is 0, this is 0, this is 0, and h is equal to x. Okay, so let's put the values in the equation. We'll get f of x is equal to f of 0 plus h f dash x 0 plus h square up sorry, we are replacing h as well, so can we say x f dash 0 plus x square upon 2 factorial f double dash 0 and x cube upon 3 factorial f triple dash 0 and so on. The last term will be x n divided by n factorial fn of theta x. Okay, and the last term is called as the Maclaurin form of that's the in the same case like Lagrange's form of remainder. So this is called as Maclaurin's theorem with Lagrange's form of remainder. Okay, now let's move on to Maclaurin series and do some of the numericals based on this. So Maclaurin's series, what is Maclaurin series? Okay, let's say if we are replacing this equation number 2 as an infinite series, so if fx is expressed as an infinite series, then fx is written as f of 0 plus x f dash 0 plus x square upon 2 factorial f double dash 0 and x cube upon 3 factorial f triple dash 0 and so on to infinity. This is called as Maclaurin's series. Okay, and let me here if Rn tends to 0 because as n will be reaches to infinity, then the Lagrange's form of remainder would be 0. Hence the Maclaurin theorems converted into Maclaurin series. Okay, so let me do the question for you which may be asked in your academic examinations. Using Maclaurin series, expand tan x up to term containing x to the power 5. Okay, so how do we solve this thing? If you recall this expansion of tan x, then what's the tan x formula? Tan x series is given as x plus x cube by 3 plus 2 by 15 x to the power 5. Ultimately our result should be like this. Let's see our result comes like this or not. So in order to find the expansion of tan x, let's first consider the function fx equal to tan x. Okay, we have to consider up to third order of derivative, so simultaneously we have to calculate the value of 0 as well. The function value of tan x at 0, can we say tan 0 is 0. What is f dash x? First order, what is the derivative of tan x is sec square x. So what is f dash 0? Can we say sec square 0, and sec 0 is 1, so sec square 0 is also 1. Okay, let's talk about the second derivative. So how do we find the second derivative? What's the derivative of sec square x? Can we say this is nothing but 2 sec x, and the further derivative of sec x is sec x into tan x. Okay, so what's our final answer? 2 sec square x tan x. Now calculate the second order derivative at 0. Can we say the tan x term is there, so tan 0 will be 0 and this will make the term as 0. Let's talk about the third derivative. So what is third derivative? Let 2 as constant and there are two terms, this one, this one. So how do we differentiate? uh, the product apply the product rule, a into b. We take a as constant, differentiate the second, and take b as constant and differentiate the first. So let's sec square x as constant, and what's the differentiation of tan x? Can we say sec square x and take sec x as constant, and what's the differentiation of sec square x? 2 into sec x and sec x into tan x. Okay, so what's the final answer? Can we say 2 into sec to the power 4x plus 2 into sec square x tan square x. Okay, so let's uh, calculate the value at third derivative, and this will be sec. So 2 into this will be 1, okay, and this will be 0. So can we say the answer is 2? Okay, now let's talk about the fourth derivative. So fourth derivative, take 2 as constant. What is the derivative of sec to the power 4x? 4 sec cube x. And what's the further derivative of sec x? Sec x into tan x. Okay, plus 2. And now derivate the following terms. So sec square x, let's first take it as constant. And what's the derivative of tan x? Can we say 2 tan x and sec square x plus tan square x, make the second term as constant and take the derivative of 2 sec x and sec x into tan x. Okay, and when we go on calculating the things, then the fourth derivative is coming to be 0. Okay, in the same fashion you can also calculate the fifth derivative as well. As I'm not writing the doing the results for you, you just calculate it by your own, just to make the things more conceptual for you, and you will practice it more, and just you will find that the value of fifth derivative is 16. So what's the Maclaurin series says? Fx is equals to f of 0 x into f dash 0 plus x square by 2 factorial f dash 0 plus x cube upon 3 factorial f third derivative of 0, x to the power 4 upon 4 factorial f fourth derivative of 0, x to the power 5 upon 5 factorial f fifth derivative of 0, and so on. Okay, let's write down the values from the top. Here you can see f of 0 is 0, f dash 0 is 1. Okay, so let's write down the result. X into 1 x plus what is double derivative 0? This is 0. So second third term will be getting cancelled. What is this? This is 2. So can we say 2x cube upon 3 factorial plus fourth derivative is 0, fifth derivative is 16. So can we say 16 by 5 factorial into x to the power 5. Let's simplify this. Can we say x plus 2 into x cube, 3 factorial means 3 into 2 plus 16 means 5 into 4 into 3 into 2 into 1 x to the power 5. What's our final answer? X plus this 2 will be getting cancelled, x cube by 3 plus 4 4 2 2, so 2 by 15 x to the power 5. If you can see, in the very starting we written over here the expansion of tan x, and again by the Maclaurin series we are getting the same answer, hence our calculation is correct. Okay, uh, but sometimes in the Maclaurin series, if you want to calculate for some of the difficult term, so you can utilize the direct standard results of series. So let me write some of the series for you, that is formulas by expansion. Some of the expansion which you will be required in your questions. Okay, so 1 plus x to the power n is equals to 1 plus nx n into n minus 1 upon 2 factorial into x square plus n into n minus 1 n minus 2 upon 3 factorial and x cube and so on. Okay, 1 plus x to the power minus 1 is given as 1 minus x plus x square minus x cube plus x. You need to remember all these things, okay, because no cheat sheet will be you won't be able to take the cheat sheet of this in your examination, so you need to remember and just practice it by writing the things consecutively. Okay, and expansion of e to the power x is 1 plus x square upon 2 factorial x cube upon 3 factorial and so on. Okay, what's the expansion of sin x? X minus x cube upon 3 factorial plus x to the power 5 upon 5 factorial minus x to the power 7 upon 7 factorial. Cos x is given as 1 minus x square upon 2 factorial plus x to the power 4 by 4 factorial minus x to the power 6 upon 6 factorial. And just now we have studied about the expansion of tan x, that is x plus x cube by 3 plus 2 by 15 x to the power 5. Can we say expansion of log of 1 plus x is given as x minus x square by 2 plus x cube by 3 minus x to the power 4 log of 1 minus x is equals to minus of x plus x square by 2 plus x cube by 3 plus x to the power 4 by 4 and so on. But which of the expansion you are only required to learn? This is e to the power x, sin x, cos x, tan x and 1 plus x to the power n. Okay, so let me solve a numerical for you by the both method. What's the next question? Question is like this: expand e to the power sin x by Maclaurin series. Remember, here it is mentioned by Maclaurin series or otherwise, so we can also use the otherwise method up to term containing x to the power 4. Okay, so how do we solve this? We know the expansion of e to the power x is 1 plus x square upon 2 factorial x cube upon 3 factorial and so on. Remember to consider up to x cube because it has been mentioned x to the power 4 here. So e to the power sin x is nothing but just replace the values of x as sin x. So can we say 1 plus sin x plus sin x का whole square divided by 2 factorial plus sin x 3 and this is cube. Okay, so let's further write the expansion of sin x. So what is the expansion of sin x? X minus x cube upon 3 factorial plus x to the power 6 upon x to the power 5 upon 5 factorial. Okay, again 1 upon 2 factorial, take it as common, and can we say x minus x cube upon 3 factorial. We are not writing the x to the power 5 term because x to the power 5 and the squaring of this will be x to the power 10. We are only interested up to term of x to the power 4. Okay, plus 1 upon 3 factorial x minus x cube upon 3 factorial to the power cube and 1 upon let me write one more term, x to the power 4 by 4 factorial. Okay, so 1 upon 4 factorial x minus x cube by 3 factorial to the power 4. Now here x to the power 4 will come, so we not need to proceed for next term also. Okay, now 1 plus x cube by 3 factorial will be 6. Okay, and we are not writing the x to the power 5 term because that is not required, because in the question it is asked to express up to x to the power 4. Can we say 1 upon 2 factorial is 2 and this is squaring, so can we say x square minus x to the power 4 upon 3 factorial x to the power 4 upon, because if you want to calculate the square, what is a minus b square? Let me do it for here just to make the things. 3 factorial is nothing but 6. Okay, so can we say a minus b square is x square plus x to the power 6 by 36 minus 2 into x cube by 6. Can we say this is 3, and the final answer is x square minus x cube by 3, and x to the power 4 by x cube here, so x to the power 4 by 3. So directly we are writing the results here, and I made it understood over here because you will be confused if you how this result has arrived. So you can refer always this thing. So let me rub it and move further. So again in the same fashion, 1 upon 3 factorial, write the a minus b cube. So only a minus b cube here is x cube. Okay, and next term is not required. 1 upon 24, and this is x to the power 4, and so on. So when you will solve this thing, okay, you will find that the expansion is coming as 1 plus x square by 2 and x minus of x to the power 4 by 8. Okay, you do it. Okay, you will check the calculation and all will find the things very easy for you to calculate. But we are learning the concepts of Maclaurin series, so let's do it by the Maclaurin series. This is method number 2. Okay, so what is fx? Fx is nothing but e to the power sin x. So f of 0 will be e to the power sin 0 is sin 0 is 0, so e to the power 0 is 1. Let's take the first order derivative. So what is the derivative of e to the power x? E to the power x ka derivative e to the power x itself, but here it is e to the power sin x, so sin x will be differentiated further. Okay, now can we say this can be also written as fx into cos x, and we have calculated the value of f of 0. So f dash 0 is nothing but f of 0 into cos of x, or cos of 0. So f of 0 is 1, cos of 0 is 1, so this is also 1. Let's take the second term, f dash x. Okay, in order to simplify the things, we'll write fx. Okay, so first we'll differentiate fx and keep the second constant, and keep the first as constant, and this is minus sin x. Okay, so let's calculate the second order derivative at 0. Can we say answer is f dash 0, or f dash 0 into cos of 0 minus sin of 0 into f of 0. So f dash 0 is 1, cos 0 1, sin 0 0, f0 1. So can we say the answer is 1 again. Let me do the third derivative for you, f3 dash. Okay, so can we say again, let's solve this one. Okay, so f double dash x into cos x, okay, plus cos x sorry f dash x into cos x derivation minus of sin x. So this is your first term. Now let's talk about the second term. Can we say minus, we'll put here, then f dash x into sin x plus sin x, or plus f of x into cos x. You can if you like unable to understand the things, you do it by your own, because I'm writing the results directly, and once you practice what we have just did, we just implemented the product rule. What's product rule? Keep the first as constant, differentiate the second, keep the second as constant, and differentiate the first. Okay, this is the simple method. So once we'll calculate the accordingly third derivative as 0. Okay, you will find that the third derivative is coming 0. Okay, simultaneously the fourth derivative is f3 of x, f3 means third derivative of cos x, minus f2x of sin x, okay, minus 2 of f2x and sin x, and f of x into cos of x, okay, minus, now let's talk about this portion. So f dash x into cos of x minus f of x into sin x, okay. So let me make the things easier for you. What did we keep this as constant and then differentiated this one, okay. We took this as constant and cos x a differentiation minus sin x, clear. Let's talk about the second term, or what, here let's write down one more step just to make the things easier, for because there are some terms similar, because this is similar, this is similar. So minus 2 f dash x sin x minus f of x cos x, okay. So first term we have already solved. Let's talk about the second term. Minus 2 is same here. Keep the sin x as constant and differentiate f dash x. This is f1 dash will be converted to f2 dash, okay. Plus, now consider this as constant and differentiation of sin x is cos x. Now second term is solved. Let's talk about the third term. Minus minus, keep constant cos x as constant and derivative of fx is f dash x, okay, plus f dash x and the derivative of cos x is minus sin x. That's the reason minus sign has been involved here, okay. Now you can easily calculate the fourth derivative, and this is coming to be 3, and we are only interested up to term 4, so we need not to further calculate. So now if we remember what's our Maclaurin series, f of x is given as f of 0 plus s f dash 0 plus x square upon 2 factorial f double dash 0 plus x cube upon 3 factorial f triple dash 0 and x to the power 4 by 4 factorial f fourth derivative of 0. Let's write down the values. F of 0 is 1, f dash 0 is 1, f double dash 0 is 1, f triple dash 0 is 0, and this is 3. Okay, so can we say this is 1 plus x square upon 2 factorial बोले तो 2 प्लस x to the power 4 फैक्टोरियल बोले तो 4 into 3 into 2 12 24 24 and this is 3, so this will be 8, and here this is minus 3, the value will be minus 3, okay. So what is the answer? Can we say 1 plus x square by 2 minus x to the power 4 by 8. Let me check whether the answers are same as in method 1 or 2. You can see the answer is same, okay, and we are interested up to term 4 only, okay. Now let's move on to the next, that is Taylor series. Taylor series is also similar to Maclaurin series, and it has been derived from the Taylor's theorem as well. So let's further move on to Taylor series. So what's Taylor series? If x plus h can be expressed as infinite series, then the Lagrange's form of remainder becomes 0, and the Taylor's theorem converted to Taylor series like this. F of x plus h is given as f of x plus h f dash x plus h square upon 2 factorial f double derivative of x plus h cube upon 3 factorial f triple derivative of x, and so on to infinity. So this is Taylor series, okay. Let us say if we replace x by a and h by x minus a. ओके, कैन वी से x को हम a से रिप्लेस कर रहे हैं a एंड h को हम लोग x माइनस a से रिप्लेस कर रहे हैं. तो कैन वी से f ऑफ a प्लस x माइनस a f डैश ऑफ a x minus a whole square upon 2 factorial f double dash of a and x minus a cube divided by 3 factorial f triple dash of a and so on. Okay, and this is nothing but equal to f of x. Okay, if we take a as 0, if we take a as 0, can we say the upper series converted to nothing but your Maclaurin series? If we recall in the last numerical, this is nothing but Maclaurin series. Okay, so though we are interested only this portion, but sometimes the numerical is asked to set up the things in the, like the next question is like this: expand log x in the power of x minus 1. So here if we compare, how do we bring the x minus 1? We'll take a as 1. Okay, let me do a numerical for you just to make it more easier for you to understand the things. Expand log of x in power of x minus 1, hence evaluate log e 1.4 up to 4 decimal places. Okay, how do we solve this thing? So let's first consider the fx. So what is fx? Log of fx. So here if you compare x minus 1 as x minus a, then what is the value of a? A is nothing but 1, and we needed the value of f of a. So f of a bole to f of 1, and can we say f of 1 is log 1 is 0. F dash x, what is the differentiation of log x? Is 1 upon x. So again f dash 1 is 1, 1 by 1 is 1. F double dash is minus 1 upon x square. So f double dash of 1 is minus 1. F third derivative of x is 2 upon x cube. F triple derivative at 1 is 2. F fourth derivative at x is minus 6 to the power x to the power 4, and a fourth derivative at 1 is minus 6. Okay, so now if we recall the second series over here, okay, let me write the second series for here. Fx is given as f of a, or basically f of 1 plus x minus 1 f dash 1 plus x minus 1 to whole square divided by 2 factorial f double dash of 1 plus x minus 1 का whole cube divided by 3 factorial f triple dash 1 plus x minus 1 to the power cube upon 4 factorial f fourth of 1. Okay, let's write down the values one by one. Can we say f of 1 is 0, f dash 1 is 1, f double dash 1 is minus 1, f triple dash is 2, and this is minus 6. Okay, so let's write down the values. First term will be 0. Can we say the second term is x minus 1, third term is x minus 1 ka whole square divided by 2 factorial, and minus we have already multiplied, plus x minus 1 ka cube divided by 3 factorial is 3 into 2, and this is 2, so 2 will be getting cancelled. Again minus of 6x minus 1 to the power 4 by 4 into 3 into 2 into 1, 3 and 2 will be getting cancelled. So what's our final answer? X minus 1 minus of x minus 1 ka whole square upon 2 plus x minus 1 ka whole cube upon 3 minus x minus 1 to the power 4 by 4, and so on. So this is the expansion of log x. Okay, so you just find out the expansion of log x. but in the question it is being asked to calculate the values of 1.1. So put x is equal to 1.1, you will get the value of log 1.1. so do the same, 1.1 minus 1, 1.1 minus 1 का whole square divided by 2, 1.1 minus 1 का whole cube divided by 3, 1.1 minus 1 का power 4 divided by 4, and so on. Or can we say this is 0.1, this is minus 0.005, and this will come around 1/3. Okay, the 0.003, and the last will be 0.0002, and if we calculate this thing, this is 0.0953. So log of 1.1 is this one as far as the Taylor series is concerned. Okay, so this is all about the Taylor's theorem and Taylor series and Maclaurin series. You just need to remember a single formula, that is Taylor's theorem. Okay, once you remember Taylor's theorem, you can easily derive the Taylor series as well as you can easily derive the Maclaurin.